Hi, I'm Captech from New Retro Repair, otherwise known as Dan, and in this video I'll be detailing how to repair a damaged PCB trace. And to do so we're going to need a few basic tools. Now, one of the most important things you're going to need, and it is required obviously, is a soldering station or a soldering iron. I recommend a soldering station like this one. This is a KSGER or KSGER, don't really know how to say it, T12 station, and they're cheap. They retail for approximately, or give or take, £25–30 with shipping from AliExpress, and they tend to come with these. This is a little soldering handle, and they come with detachable soldering bits as well, which is nice. These have a heating element in the center and a temperature sensor, and the microcontroller on board the soldering station will control the temperature of the iron, and it just makes soldering a lot easier than the traditional style soldering irons. You're also going to need some kind of soldering stand and something to clean your iron tip with. You can use a damp sponge or a brass ball like I do, and let's face it, who doesn't want brass balls? You're also going to need some of this, and this is enameled wire. It's a copper wire with a enameled insulating layer around it, and you're going to want some solder. In this case it's leaded solder. This is 6337 tin lead solder. You're going to need some isopropyl alcohol. In this case I have this little container which only costs a few pounds off eBay, and it comes with this convenient little nozzle that allows us to direct it. You're also going to need some precision tweezers. I have these, they're pretty good, they're cheap, you know, you can buy them in multi-packs. You're going to need some kind of brush. You can use a toothbrush for this as well. I'm not going to detail where you get those from, because if you don't know, you've got bigger problems. You're going to want something to do some scraping on the PCB. I use these. This is a Swan Morton scalpel blade that's curved, and that curve just helps scrape because it allows the blade to sit a little flatter to the board and you to angle your hand a bit better, so these are really handy to have. You're going to need some good quality flux as well. You want a no clean tacky style flux. This one is Kingbo RMA 218, and this is pretty good stuff. It's also really cheap, so it's worth having that. And although I don't use it in this video because I don't make any mistakes in what we're doing, it is pretty common to make mistakes, and of course I do make frequent mistakes when I'm doing repair work. And not only that, but it's good for cleaning things up. You'll need some of this. This is desoldering wick. This is chem wick, so it's infused with rosin flux as it is, and it's really good stuff. It just sort of sucks up all the solder through capillary action, which is great because it's no effort. And I think that's about everything you'll need for this. And what we'll be doing is damaging a PCB track on this board. This is an old NES, it's dead, so we're going to scratch up one of the PCB traces, and then we're going to go ahead and repair it using some enameled wire. I'm not going to create a huge gap on the track, on the trace. We're just going to break it and then re-establish continuity using a piece of enameled wire. Because the break we're going to make in this video is so small, in reality you could use a solder bridge to repair it, but in this case I'm demonstrating the usage of enameled wire to repair a damaged track, so that's what we're going to do. So I hope you enjoy the content, and I hope you learned something, and let's get on with it. So as I detailed, this is the board that we're going to damage. Now, as you can see, we've got multiple traces here, and actually all these traces are good, so we're going to have to damage one. So I'm going to use that scalpel blade I've detailed earlier, and what I'm going to do is I'm going to purposefully damage this track. So what I'll do is I'll scrape away a bit, and you can see that that factory installed solder mask is coming right off. So there we go. Now, in a real life situation, obviously the damage is not going to be necessarily as obvious as this, but yeah, so again, as I say, we need to damage this track, and I need to scrape away a bit more to actually damage it. So we'll just keep scraping until we've got rid of the copper. As you can see, that copper's coming away. I'll keep going keep going until we've got rid of enough copper to break the track. And we're nearly there. We've only got a very thin piece left now. And there we go. We've sliced through that quite well, I think. Yep. That has completely destroyed that track. I'm just going to brush that away and zoom in to show you just how messed up that track now is. So if we zoom, you can probably now see that that track, we can get the focus just a little bit better, is now not complete anymore. So let me get that just a bit better. It takes a little bit of fiddling around with this microscope, but yeah, there we go. You can probably see that that is broke. That should no longer have continuity across that track. So I'm going to switch my multimeter into continuity mode. And what continuity mode allows us to do is check between two different points in a circuit to see if there's a connection. So if I were to, for example, put one probe just there, and then another probe on that piece of copper that's sticking out, we should hear it beep. There we go. So there's continuity between those 2 points. However, if I now touch this side where I've deliberately broken this track, you can see, well, you can hear that there is no continuity, there's no beep. So there we go. So now obviously in the real world we would have to repair this to, you know, get the flow of electrons back to how we want. So I'm going to get back in here with the blade, and I'm just going to clean up some of this copper shavings that we can see here. Just get that off the board. There we go. So what we'll need to do is strip back some of the PCB track so that we can solder our enameled wire on. So what I'm going to do is get in with the blade. Just make sure this is in shot. There we go. What I'll do is I'll get in with the blade just about there, and we'll strip back some of this PCB mask. So you just scrape at it lightly. Don't use any real force. All we're trying to do is remove this green solder mask. And what we'll do is we'll go along the trace and we'll remove as much of it as we can. So we'll scrape with our blade, as you can see me doing. And you get that green powder, which is the solder mask, coming away. And what we're trying to do is expose enough of the copper to solder to. And what we'll be doing is we'll be tinning this track with a bit of solder. So, you know, we just continue to scrape away lightly and get as much of the debris out of the way as you can. And as you can see, that's coming up nicely. And we just continue to scrape until we've got enough of that exposed. As I say, I'm going to do this both sides of the break that we've got. In the real world, you might need to run much longer wire than I'm planning to do for this video, but the general principle will be exactly the same. And again, this trace is absolutely massive. So again, we're just sort of scraping along the line and getting it nice and clean of the excessive solder mask. And then what I'm going to do is just brush away the debris. It's not harmful in any way. The only thing it might do is interfere with making a decent connection. And as you can see, we've got most of that solder mask off. So what I'm going to do now is, as I detailed earlier, I've got IPA. So I'm going to just drip some IPA on there, and that'll help rinse away whatever other crap we've still got left behind. And there we go. So we'll just brush away the debris. And there we go. That's one side stripped away. Now we'll repeat that exact same procedure on the other side of the break. So just sort of here, and you can just about see where the break is on the left hand side there. So again, we just come in with our blade, and you know, we'll strip away the solder mask. So it's a bit of an awkward position, so sometimes you'll have to reposition your PCB like that. And I'm right-handed, which makes this awkward because there's a little capacitor in the way. Let me make sure I get that nicely into view. There we go. And what we'll do is we'll scrape away here too. So again, just come in with the blade and just scrape. And that takes that UV solder mask away. Well, this may not be UV solder mask, but it takes the solder mask on the board away. So there we go. Just keep going. Get a nice bit exposed. And that's it. Now this skill of repairing PCB tracks is an invaluable skill to have. You'll need this to do quite a lot of repairs that you might come across. So again, we're not really trying to remove the copper from the board. It doesn't matter if we remove a little bit, like I've done. We try not to scrape too hard, and with the more modern PCBs you can get quite thin tracks which are very easy to damage, so you'll probably have to be more careful than I'm being right now. But again, this is an older board where there's quite a good amount of track there and copper material. So, you know, we just go ahead now, we clean the site. And cleaning the site does two things. It removes any oxides or anything like that, any corrosion or any other nastiness, because the key to making good solder joints is a clean area. Everything should be as clean as it possibly can be. And there we go, we can see that we've now got that area quite nicely cleaned up. And isopropyl alcohol is absolutely ideal for cleaning up this sort of thing. So what I'll do now is I'll power up my soldering iron. And because we're going to be working with leaded solder, I keep the soldering iron's temperature relatively low, relatively speaking. I have it set to 350 degrees Celsius, so plenty hot enough to melt the solder, not so hot that we're going to get a lot of oxidization. And what we'll do is just take a break because my doorbell just rang. Apologies for that. Interruptions happen, unfortunately. So, as I was saying, what we do is we get some flux down. And again, this is something I detailed earlier in the video. And what that does is it helps reduce the amount of oxidization on these joints as we solder. So, putting that down on the trace, like I've just done here, will allow the solder to take much easier to where we're going to be soldering. And what I'm going to be doing is pre-tinning this trace before using the enameled wire. And the reason we do that is because it just makes things that little bit easier to tack into place. So, as I say, I preheated my iron to 350 degrees Celsius, and what I'll be doing now is I'll be taking a piece of that solder that I showed earlier, leaded solder, and I'll show this under the scope, and I'll be tinning the end of the iron with the solder. So we just sort of blob it on like that. And what we then do is sort of hover it just above the trace and just sort of wiggle it back and forth. You can see that that's now turned to a silver colour, and that's the solder now taken to the trace. And we can see that we've got a very nice sort of clean join there. And we don't care if this solder gets onto the other track where I scraped away some of the mask. It's not a big deal. But as we can see, we now have a thin coating of solder on that trace. And the next thing we need to do is restore that continuity. So to do that, we get a piece of our enameled wire. In this case, I'm going to be using a thicker gauged enameled wire to sort of match the track. And as we can see, that's a pretty thick gauge, and that's not too bad. So what we'll do is we'll take our wire snippers and we'll snip it to approximately the size of the break. It doesn't have to be exactly the size, it can be a bit bigger. I will be making it a little bit bigger and then snipping it down to its correct size when we're done. And we can use our scalpel blade or X-Acto blade or whatever else it is that you're using to snip it back into place. Now, as we can see, we line up this on the board like that, doesn't have to be exact. Now that flux is a tacky flux. It acts like a kind of glue. So it sort of holds it into position. So what I'm going to do is take my tweezers and I'm going to put it into position as best I can, like that. And then we're going to solder it in position. And to solder it, the heat from the soldering iron will remove some of that enamelled coating. So I'll be holding the wire with the tweezers with one hand, which is a bit wobbly, like that, and I'll be coming down on top with the iron. And as we hold the iron here, it will melt away the enamel coating. This isn't going so well, but there we go. And that should start to take away the enamel coating. At the minute this won't solder because of the coating. Now remember how I said it's non-conductive? Yeah, that's not going. So what I'm going to do, I'm going to switch it up because that is not working. And I'm going to take my my scalpel blade and just strip some of the enamel coating right off with mechanical action. So we'll hold this in place and we'll just scrape the wire like this, and there we go. We can see that coating now coming off, and you see how it's leaving that crusty stuff? That's the coating. So we'll just sort of spin the wire around and scrape. Spin the wire and scrape. You could probably just turn the heat of your iron up high. I'll do that in a moment actually and see how that does for us. But the point is, we want to remove as much of this coating stuff as we can. We're not really trying to shave the copper, we're just trying to shave off the enamelled coating. As we can see, we now have a good amount of that exposed. You just sort of keep going. Get as much of it off as we can. And there we go. This is starting to look like a pretty well stripped off wire. So I'm going to leave it there and I'm just going to blob a bit more IPA on just to clean it up a bit. And then we'll come in with that brush again from earlier and we will brush away the debris, because again, as I say, cleanliness is one of the most important parts about getting a successful solder joint. So we'll just come in and clean up as good as we can. There we go. And as we can see, that wire is pretty well stripped back now. And I'm going to turn my iron up to 430 degrees Celsius, which is very, very hot. And I'm going to position the wire again using the soldering iron. It smells like hospital, so that means it's melting properly. And then we'll come down here and we'll try and melt away the enamel coating at this part with the iron, because it's now at ridiculous temperatures. This wire seems to have quite a large amount of this this enamelled coating on it. So again, we just pulled that wire away from its joint. You don't have to worry too much about that. But just use the heat of your iron to get as much of the enamel coating stuff on that's on there off. You can see it is coming off. And as you can see, because the temperature of the iron is so hot, there's a thick layer of oxidation on there. So what we'll do is just push it into that brass ball. Push it in a few times, and then as we come back you can see the iron is less oxidized, but it's already starting to oxidize because it's at such a high temperature. That's to be expected. Just position that wire back. There we go. And we're just sort of holding it in place. There we are. And I'm going to add some more flux now. And I'm going to tin the tip of my iron again. And I'm going to come in now on top with the solder, and see if we can get it soldered into place properly. Apparently not. Do apologise, this is a little fiddly. That is, however, largely soldered into place. It's because as I touch it with the iron, it conducts the heat and holds the heat, just like the soldering iron tip. So we're essentially turning the wire itself into a soldering iron. So if you just sort of position as best you can, and you can see some of that enamelization now has melted better as well, and the wire's tinned. So there we go, and there we go. And what you can now do, that is soldered into place. I know it looks a mess, but we can clean that up. But what you should do now is come in with your tweezers and nudge the wire, and if it doesn't move, as this isn't doing, we know we've got a good solder join there. And you can kind of bend the wire into place a little, like I've done there, and that's great. So then what we do is we come in with some IPA and we'll clean the site up again. Again, as I say, keep things as clean as you can. So we've got some IPA down, and I'm going to come in now with a cotton bud or a Q-tip, and I'm just going to clean away as much of the nasty debris as we can. Some of this is flux as well, and some of it's burnt enamelled wire. It doesn't affect it so much, but there we go. So that's coming off. As I say, the IPA acts as a I'll get that solder ball off. It acts as a solvent, and it dissolves flux and other nasties that we leave behind. So then, you know, just scrub away a bit, as I'm doing here. We can see that's coming up nice and clean. And don't get me wrong, it's not a perfectly straight piece of wire, but it looks reasonable. And now what you can do is you can come in with your blade and you can slice into the enamelled wire like that. And that allows us to then trim it. So we'll just trim away this part as well, like that. You could use your wire snippers to do that as well. And we'll remove the excess wire with our tweezers. If we can get a good grip on it. And there we go. And so we're most of the way there with this repair now, but obviously, like with anything, you do want to check that your repair has actually worked. So, for the purposes of this video, I'm going to scrape away a little bit of the track. You probably don't want to do this when you've done an actual repair, although there's nothing wrong with actually doing it, so long as you cover it with some solder mask when you're done. So I'll scratch away a little bit on this side. Now remember that we had a broken track with no continuity, so we'll scrape away just here, and this is just so we've got enough solder mask to put our well, enough copper of the trace, should I say, to put our probes of our multimeter on. So we'll scrape that side, and we'll scrape just over here as well, away from the wire a bit. And again, we're not too bothered about making that much of a mess. There we go. Again, if you're working with much smaller electronics, anything more modern, if you do scrape away solder mask, you're going to have to be a lot more precise than I was just being there. But again, this is just for the purposes of this video. So there we go. That's scraped away. So if I can get this into better view, maybe we can get both sides. So there we go. There's both sides now. We can see both sides of this in view. Now I'll take the multimeter again. Yeah, remember we're in continuity mode, so I'm going back to continuity mode. And when we touch the probes, we'll get a beep. As you can see. So if this track was broken, we would hear no beep when we touch one probe there and one probe there. But now we have restored continuity. So that track is now repaired. Well, most of this repair is now done, but again, we want to make sure that we've made a lasting repair, and to make a lasting repair we need to use the UV solder mask. So I'll clean the area and talk slightly condescendingly for some reason. Don't ask me why, I don't know. I guess this is my pre-recorded voice. But yeah, we'll get that down, and then what we want to do is we want to wait for the isopropyl alcohol to evaporate. I'm going to accelerate the process using a hot air station, but you can just wait. There we go, that's now dried, and the isopropyl alcohol is all gone. So, the next stage is to take your UV solder mask, and what I like to do is use a Q-tip or cotton bud, and just put a small amount of the solder mask onto the Q-tip. Now that's a lot. If you do put too much on, just dab it off onto something. You don't need a crap load of this. And what we then do is we paint it on with our Q-tip, like so. And this stuff is somewhat viscous, so it should sort of congeal over wherever you paint it fairly well. I'm going to paint it over the points that we scraped away as well. And if you just sort of dab, you can thin it out a little bit and make it look a little bit more like the original if you want to. You don't have to. But as you can see, that is a liquid, and that is now coated in a green substance. That is our PCB UV solder mask. And as I showed earlier in the video, we need to cure this using ultraviolet light. You can use an ultraviolet flashlight. I like to use a laser because it's quicker. So I'm not sure how well the laser is showing on the camera. It looks to be showing quite well. And what we do is we shine the light back and forth over this green solder mask. What that'll do is cure it and make it solid. And there we go. We've now we should have now cured that. I'm going to tap on it with a pair of tweezers just to see if that takes any of the solder mask off. It shouldn't. No, we're good. That's cured now. And then what we'll do Let's test once again for continuity on top of that wire. And if we no longer have continuity on top of that wire, we know that that track is protected. You see how we get no buzz now? That wire is now sealed in and properly protected from the elements. And it also means we can't accidentally short other things against it, or, you know, any other thing that might be a bit daft to do. And finally, as is with any kind of electronics repair, clean up the area. So just a bit of isopropyl alcohol and a cotton bud, or a brush with isopropyl alcohol, and we just come in and we clean the area as best we can. You don't have to go crazy on this. We're not trying to strip off the new solder mask. But you can also see that that solder mask isn't going anywhere. You know, this isn't stripping it off, even though it's a solvent, which is good. And that's it. And as I say, this stuff as well, it's heat resistant, this solder mask. So if you repair a track near something that you need to solder with a soldering iron or a hot air station or something like that, your wire won't move. And that's it. That's it. That's a successful repair. So I hope you found the content of this video useful, and if you have any questions or comments, leave them in the comment section down below. And as always, bye for now.